Hello everybody, today we are going to study the Venn diagram. A Venn diagram is a pictorial representation of sets. It was named after John Venn, the British mathematician who developed it. A Venn diagram basically uses a rectangle and circles inside a rectangle. So in a Venn diagram, the universal set is represented by the interior of a rectangle and the sets or subsets are represented by the interior of a circle. So this is how we draw a Venn diagram. We draw a rectangle and we mark inside U or our universal set. So everything inside the rectangle are part of the universal set. And then we draw our sets represented by circles. So suppose we have three sets, A, B, and C. And as you can see here, sets B and C have intersections. Okay? But A and B has no intersection and A and C has no intersection. If they have no intersection, we call it disjoint sets. So A and B are disjoint sets and also A and C. Now, let's have example 1. Illustrate the following sets in a Venn diagram. Let set A be the set with numbers 1, 2, 3, set B with numbers 1, 3, 5, 7, and set U or our universal set is the set with numbers 1, 2, 3, 4, 5, 6, and 7. So by using the Venn diagram, first we draw a rectangle to represent our universal set. And then we draw a circle to represent our set A. And then we will draw our set B, which is another circle. And as you can see, these two sets have an overlapping part or the intersection part because A and B have intersections. Okay, they have common elements, the numbers 1 and 3. So we put those numbers 1 and 3 in their overlapping part or in their intersection. And also, set A has the number 2. So we write 2 in set A, which is not part of the intersection. And also, in set B, we still have numbers 5 and 7. Okay, so we write those numbers inside set B, but not inside the intersection. Okay, so this is how we illustrate these two sets in a Venn diagram. And of course, part of our set U or universal set are numbers 4 and 6, but they are not inside set A or set B, so they are outside, okay? But they are inside also the rectangle because they are part of the universal set. All right, example 2. Represent the given sets using the Venn diagram. Let set F be the set with numbers 4, 5, and 6, and set G with letters R, S, and T. To represent these two sets, okay, let's draw our rectangle which represents our universal set. First, let's draw a circle to represent our set F, and we draw another circle to represent G. But as you can see here, F and G are disjoint sets. They have no common element or no common members. So we don't have their overlapping part or we don't have their intersection. So this is how you illustrate two sets which are disjoint or no intersection. And then we put their elements inside their circles. So for circle F or set F, we put 4, 5, and 6. And for circle G or set G, we put R, S, and T. Now for example 3, our set F is the set with elements 4, 5, 6, R, S, T. And our set G is the set with elements R, S, and T. So to draw the Venn diagram, first we draw a rectangle, which is our universal set. And then we draw the circle F. And then we draw another circle G. But before you draw the G, look at the elements of G. These elements of G are all inside F also. So G is a subset of F. So we draw G inside F. because all the elements of G are also elements of F. So G is an element of F. So that is how you, is a subset of F. So that is how you draw a set which is a subset of another set in a Venn diagram. And then we first put the elements of G, RST, inside the circle of G. And then the remaining elements of F, 4, 5, 6, will be written outside G but inside F, 4, 5, and 6. And this is how we illustrate F and G with common elements. Let's go to example 4. Let set A be the set with elements A, B, C, D. Set B with elements B, D, F, H. Set C with elements B, C, E, H. And our universal set is the set with elements A, B, C, D, E, F, G, H. First, we will draw our universal set. And then we draw our set A. Okay? Next, we draw our set B, or circle B. But as you can see, B and A, or A and B, have common elements, so they have an overlapping part or intersection part between A and B. And then we draw our set C. And as you can see here, our set C has a common element with A and also with B. So it has an intersection with A and also in B. And this is how we draw it. Okay? So all the three sets have a common element. Okay? They have an intersection. And what is common between A, B, and C? It is the element B. Okay? So we put the B in the region which is common for the three sets. And then let's look at A and B. Set A and B have common elements B and D. Okay? Since we already wrote the B, so we just write the D, which is common between A and B. And now let's go to B and C. What is common between B and C aside from B? Okay, it is H. Okay, set B and set C have common elements B and H. Since we already wrote B, now we just write the element H, which is common element of set B and set C. And lastly, for sets A and C, the common elements are B and C. Since we already wrote the B in the middle, so we just write the C. So those are their intersections. And then, to complete, let's go back to set A. We already wrote B, C, D. So we still have A. So we put the A now inside set A, but outside the intersections. And also in B, we still have the element F. Okay, so we put F inside B, but outside the intersections. And for set C, we still have element E. It is inside C, but outside the intersections. And our universal set also has the element G. And that element G cannot be found in A, B, or C. So we put it outside the three of them, but inside our universal set, or inside the rectangle. And this is how we represent these four sets in this Venn diagram. So this is a practice for everybody. So I want you to illustrate the following sets on a Venn diagram. Okay? You can do it. You can pause the video. You do it in your paper and you try it. Alright? Okay? Now, let me continue with set operations using Venn diagrams. So, as we have studied, set operations are the union of sets, the intersection of sets, the difference of sets, and the complement of a set. So, how do we illustrate the union of sets using Venn diagrams? Or how do we illustrate A union B? This is how we illustrate two sets A and B and their union. Okay. Again, union is the combination of the elements of A and B. So that is how we illustrate A union B in a Venn diagram. Everything that is shaded are part of A union B. How about the intersection of A and B? So A intersection B is represented by the blue area in our Venn diagram. So only that intersection part or the common part is the intersection of A and B, or our set A intersection B. How about the complement of set A, or A complement? Okay, remember, complement means outside the set. So we draw the circle A, and then we shade everything outside A. Okay, the shaded part will be everything outside A, but inside the rectangle or the universal set. And how do we illustrate the difference of sets, the difference of set A and B? So A minus B can be represented by this figure. Okay, the blue or the blue shaded area is our A minus B. It is our set A subtracted by set B. So we remove everything that are part of set B. So we are only left with the blue shaded area. So that is A minus B set. Okay, so these are the four operations on sets that are represented using Venn diagrams. Let's have our exercises. Draw a Venn diagram to represent the given set below. Number one, the union of A and C intersection with B. So this is how we draw A union C intersection B. Okay? So we are going to find the intersection of the union of A and C and the B. Okay? So the union of A and C are these two circles. And we will shade the intersection of that with set B. So we shade this area because these areas or regions here intersected with set B. Next, what is or how do we represent A minus B union C, or the difference of A and the union of B and C? This is how we do it. We have set A minus the union of B and C. So set A subtracted by the union or everything covered by B and C. Okay, so A minus the union of B and C is represented by the gray part or the shaded region. Next, how do we represent A union the intersection of B and C? This is how we do it. We have A combined with the intersection of B and C. So we shade all A, and then we also shade the intersection of B and C, this area. So everything shaded or the gray part is our A union, the quantity B intersection C. Now for our practice, let's do the following. Number one, draw the Venn diagram of the following, of each of the following sets. Set A is A intersection B minus C. So how do we draw a Venn diagram for that? Okay, this is the answer. We have two sets A and B with common part. We shade their common part or intersection, but we erase the area where they intersect the C, okay, because that is minus C. So minus or remove everything that is part of set C. So this is our answer for letter A. For letter B, what is B minus the intersection of A and C? This is the answer. Our set B subtracted by the intersection of A and C. This is the intersection of A and C, so you remove all this, so you erase all this part from B. So you are just left with this shaded region. And that shaded region is our B minus the intersection of A and C. Next, what is C union A minus B? This is the answer. We have set C union or combined with A minus B. So our A subtracted by B is the shaded region here. Combine it with everything inside the C. So this is our answer for letter C. And for letter D, what is A prime or A complement intersection with B complement union with C? This is our answer. A complement is everything outside A. B complement is everything outside B. And their intersection, okay, their intersection is everything outside these three sets, okay? Everything outside these three sets, or everything outside A and B, are part of the intersection of A complement and B complement. And then we combine that with set C. So we shade also the whole set C. And everything shaded now, or the gray part, is our answer for letter D. Now for our last practice problem, write the following set indicated. Look at the Venn diagram given. Okay, our universal set is the one inside, or everything inside the square or the rectangle. And we have three sets, sets A, B, and C. Okay, number one, what is A union B minus C? Okay, what are the elements of the set A union B minus C? So give the set which has the elements of A union B minus C. Okay, so A union A combined with B minus C. So copy all the A and then add those elements that are part of B minus C. B minus C will be XYW. That is B minus C. XYW or WXY, and then copy everything inside A. So this is our answer for number one. A, B, H, N, P, S, and then X, Y, W. For number two, what is the set A intersection B minus C? First, find the intersection of A and B. The intersection has the elements X, P, and A, right? The intersection of A and B have the elements X, P, and A. Subtract C, meaning subtract all elements of C. It means we subtract P and A because P and A are part of C. So we are only left with X. So this is a singleton set with element X only. For number three, what is B intersection C minus A? First, what is the intersection of B and C? The elements of the B and C, or the intersection of B and C, are P, A, and D. P, A, and D, this area. Subtract all the elements of A because it's minus A. So we subtract or we remove P and A. So we are left with only D. Okay, so the set with only one element, D. And the last one, what is B minus A union C? So set B minus A union C. So we remove everything that are part of A and C. So from set B, we remove everything that are part of A and C. So we remove X, P, A, and D. So we are left with W and Y only. So that is our answer for number 4. All right, so let's have another set of practice. And this time, you do it by yourself. Okay? So try to do this practice alone. And you may pause the video or you may go back a little bit in order to determine the answers of this practice exercise. Okay, so I will end the video now here, but you can continue doing the practice to master this lesson. All right, thank you for listening and watching this video.